Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yakoob. So now we are starting with the second lecture of this foundation course. And what is this foundation course all about? It's a transition class sessions actually from O levels all the way till AS level. So in the last class, some of you may be attending it for the first time. We talked about trigonometry and so on, and how to sketch a line, the distance formula, and things like that. So now in today's class, let's talk about few things. Let's first talk about algebra. So now in algebra, we can talk about expansion, we can talk about factorization, we can talk about indices, we can talk about quadratic equation, simultaneous equations, and things like that. And yes, one other thing that is about functions. So let's focus on each one of them comfortably. So now if I talk about the first thing, which is expansion. So if I talk about expansion, we all know how to expand something algebraically. For example, x multiplied with x plus 3. So this becomes x squared plus 3x. Something like x plus 1 into x plus 2. So now this will be, let me focus on this, x into x into 2. So that is x squared plus 2x. And then let's multiply this one with x and one with 2. So that is x plus 2. Now, thing that you should focus is that initially there are four terms, but these two terms are like terms. So they will add up and this thing will become x squared plus 3x plus 2. Something like three brackets, x plus 1, x plus 2, x plus 3, and that was included as part of the new syllabus. So now x plus 1, x plus 2, it's already done. That's right over here. That is x squared plus 3x plus 2. That is this thing. And then let me multiply it with x plus 3. So now let's multiply it out. And someone asked this question, sir, what is, where it is? What is sim equation? So this is actually simultaneous. So sometimes I write in a very short form and people will get used to me. So simultaneous equations. And similarly, what is this thing? This is quadratic equations. So I've answered this thing and then someone is asking, sir, I cannot hear your voice. Is this the issue at my end? Let me double check. Yes, that's the issue at your end. Okay, so let's continue the journey. So now over here, this is multiplication that is needed. So we will multiply it this way. This x square gets multiplied with x and 3. So that is x cube plus 3x square. Let me take this 3x and multiply it with x and 3. So 3x into x, that is 3x squared. 3x into 3, that is 9x. And similarly, I can take this 2 and multiply it with x, that is 2x, and 2 multiplying with 3, that is 6. Now look at the way that I'm working. Might be a little bit new to you. Yes, we learn new things in AS level maths, whether it's new concepts, whether it's new techniques. That is what AS level is all about. So this is not any rocket science. All I'm doing is this thing that I'm writing it in a neat manner. So now let me focus on this thing. So now there is one x cube term. So that is x cube that goes all the way down. This is x cube. This is 3x squared. This is 3x squared. That is 6x squared. This is 9 plus 2. That is 11. And this is the x term. And then there is one constant term, which is 6. So now what you are getting is a cubic expression. So now some terminologies. A linear expression is something in which there is x has a power of 1. A quadratic expression, this is expression. A quadratic expression is something which has a power of 2. And let me use the eraser, it's right over here. So this is linear expression, x power 1. Hold for a second. So this is x power 1, this is x power 2. A cubic equation has x power 3. So these are the three different kinds of things. So over here, this was the first example. Let me focus on this. That was the first example. This is the second example. This is the third example. And that is the answer that you are getting. So this is all about expansion over here. Now let's talk about factorization, the opposite of expansion. So factorization can be about taking common. Factorization could be about middle term breaking, middle term factorization, middle term breaking. There are different ways of naming it. Factorization is also about difference of two squares. And factorization could also be about factorization by grouping. For example, let me just start with the first one. If I say factorize the following, factorize the following. Now keep in mind, there is no equation over here. We are simply factorizing. So therefore, this is x square plus 5x. So if I want to factorize, I'll take x common out. This is x plus 5. This is factorization. So this falls into the category of common. So this one is take common. It falls under this category. A very simple example. Now let's talk about this one, factorization by grouping. So if I talk about this step, x squared plus 2x plus x plus 2, x squared plus 2x plus x plus 2. And this is factorization by grouping. So factorize by grouping, form groups. So now look at x squared, look at 2x, that's one group. Look at x, look at 2, that's the other group. So what I can do is that I can write out of the first two, x plus 2. Out of these two, I can write one common, x plus 2. Got the idea? And now this thing right over here, x plus 2, x plus 2, that can be taken common out. I can write it at the beginning. So this is x plus 2. And what is left? I'm left with x, I'm left with 1. This is x plus 1. That is factorization by grouping. Have a good look at this, and I can have a look at the this thing. Now, someone is asking, sir, what is simultaneous equation? Already answered. Difference of two squares. Please hold a bit, because that is something that I'll be explaining. I haven't explained it as yet. So no hurry, chill, relax, and things will come at the right time. So now let me also see, sir, how do I get the assurance that I'll be sitting in your class? You are sitting in my class by joining the group. Okay. If you're asking about my on-campus class, that's a separate issue. So now that is one thing. Let me look at some other one. Hold for a second. Okay. This thing is done. And okay. Now, sir, will you try 2 simple explain for differentiation and 2 squares later on? Yes, yes, it will be coming up. Okay. So now, people, I like the interest, mashallah, with which you people are taking part in it. So I talked about factorization by grouping. This thing is done. Common, this thing is done. Now let's go to the next page and take examples of middle term breaking. So now let's focus on this, and I'll be doing more examples of this. X square minus 5x plus 6, middle term breaking. Now focus on this, and which color am I using? The green color. So when we are talking about middle term breaking, focus on the coefficient of x square, focus on the constant term. So this is 1 into 6, that is 6. Break the middle term in such a way so that it adds up to negative 5x and it multiplies to give you 6. This is what you have learned. So I'll write x square minus 2x minus 3x plus 6. Now someone can say, what if I write x square minus 6x plus x plus 6? Now this is a very, very classic example of how people can get confused between two things, and only one of them is correct. Now focus on this first. There is no hurry. Just chill, relax, and things will come to you. Negative 2x, negative 3x, that is negative 5x. Negative 6x plus x, that is also negative 5x. So at the first glance, both of them seems to be correct. Now, if I factorize by grouping, in this first one, when I'll be taking common, this is x bracket x minus 2. This is negative 3 bracket x minus 2. Over here, when I'll be taking common, what will happen? X square minus 6x, that is x minus 6. This is 1x plus 6. Now, this one is definitely wrong because you cannot proceed further. Got the idea? Because these two are different. This is different from this. So you cannot proceed further because you cannot take common. Got the idea? So you cannot take common. Over here, this is 100% correct. The only correct factorization. Why is this the only correct factorization? Because you can take common. So what common can you take? X minus 2, it's already common. So this is x minus 2 and x minus 3. So that is the correct factorization. This one is totally wrong. Now let me write over there in the group. So is this example all good to go? So just put a tick mark, emoji, thumbs up, smiley face so that I know that you are following exactly what I'm doing. So let's pause for a bit. Now, sir, how to identify this at the very first side that this couldn't be solved by middle term breaking? So we have to use a quadratic formula. You learn from experience. You learn from experience, and you will also learn this thing in AS level maths in one of the chapters called quadratics. So this is wait for more details of AS level maths. And topic name is quadratics. Okay, so that is what I've answered. And let me also share this question and answer in the group. So this is over here, and I've shared it over here. Okay, people, I want more response, more faster response. How can we identify by seeing the equation? I've already answered. Okay. So now that is the first example. Now let me choose a question from here. X square plus 3x plus 2, another example. So still we are on factorization. X square plus 3x plus 2. So what we do is that we take the coefficient of x square, we take the constant term. So this is 1 into 2 is 2. So I'll write x square plus 2x plus x plus 2. Now people are also confused that what if we write this term first and this term second? Will it make a difference? Let's double check. So this is x squared plus x plus 2x plus 2. And one other thing I want to focus on, that is over here negative 2, negative 3, it multiplies to give you plus 6. Over here, negative 1, negative 6, positive 1 is not multiplying to give you plus 6. So that is also a litmus test. But if someone forgets this, not an issue, because this is where the question will tell you whether it's right or wrong. So factorizable, this is the correct factorization, this is the incorrect factorization. Not only should the equation be unchanged, at the same time the coefficients should multiply to give you this thing multiplying with this. All good? The same goes over here. This is the same thing written twice. The only difference is I have written 2x first, x later. I have written x first, 2x later. Doesn't make a difference. So now over here, I'll write x common, x plus 2, 1 common, x plus 2. If these two are the same, you can proceed. So this is x plus 2. Choose the x, choose the 1. That is x plus 1. Similarly, over here, this is x squared and x. So that is x bracket x plus 1, 2x and 2. That is 2 common x plus 1. Again, these two are exactly the same. That is x plus 1 and this is x plus 2. So far, so good. So I hope this is all got all clear. Let me just double check this thing. So now let's proceed. So this third thing is done. This one was about middle term factorization. So this I'm writing it as MTF. You will get used to my symbols. So this is an example of middle term factorization. This is an example of middle term factorization. Now what is left? Now we are talking about difference of two squares. So this is the most interesting part. If I multiply a plus b into a plus b, this is a square plus ab plus ba plus b square. This becomes a square plus 2ab plus b square. This is one example. If I multiply a minus b into a minus b, that is a square minus ab minus ba plus b square, which is a square minus 2ab plus b square. Now this can be written as a plus b whole square, and this one is technically a minus b whole square. Now focus on this. How many terms are there on the inside? So this is two terms on the inside, a positive sign, squaring it, you finally end up with three terms. All have a positive sign. Over here, there is a minus sign in the middle, you are squaring it. You end up with three terms. The first one is positive, second one is negative, third one is positive. Got it? Now, what if you multiply a plus b into a minus b? So now this is a into a, that is a square. Then you have a into negative b, negative ab. Then you have b into a, that is positive ba. Then you have b into negative b square. What happens? These two terms cancels out and you are left with a square minus b square. So now this is what interests me, because if I write it like this, a square minus b square, that is a plus b, a minus b, this is known as difference of two squares. And as the name suggests, it's very, very clear. There is a difference of two squares. This is square, this is square. There is this, the difference, which is negative sign. This is difference of two squares. So this is a plus b, a minus b. Is this all good, all clear? Have a good look and acknowledge a bit difference of two squares. So is this all good, all clear? So I've written it in the group, double check. Okay. Now, some people might be thinking that, sir, why are we doing this thing so basic? Now, the thing is, this basic thing that you are thinking about in AS level maths, when you start a new concept, that concept boils down to this O level thing, and not everyone is up to the mark. So your working is based on O levels. And believe me, people think it's easy, and those are the ones not scoring the proper mark. Now, let me just show you something. This is an example of a past paper question. A straight line has a gradient m passes through the point such and such, and find the two values of m for which the line is a tangent to the curve. Now, this is the curve equation. This is the line equation. You make a single equation, and now look at what they are doing. They are simplifying things. They are applying some concept that is about a b square minus 4ac. So that's the value of b, that's the value of a, that's the value of c. And now what is this? Isn't this O level maths? Isn't this solving for M? Yes, it is. So now people do not underestimate O level maths. O level maths will be used in AS level, in A2 level. After you find the different values of M, you plug it in, you do middle term factorization. This is AS level maths. And people get stuck over here. This is another chapter, something like differentiation. And look at the working over here. This is all from one of the courses that I have taught. What you see is things over here. New rules are there, but the working is all based on indices. It's all based on powers. It's all based on simplification. So do not underestimate O level maths. Yes, that is what I'm revising so that the gap is bridged so that there is a smooth transition. So now, people, this syllabus, these 5 courses is for the smooth transition from O levels to AS level. Because if this transition is not smooth, you will be having a lot of difficulty in AS level maths. I think I have made myself very, very clear. Okay, Ji. So now this thing is done. So I talked about these 4 things. That is factorization by grouping, factorization by common, middle term breaking, difference of two squares. Now, how will they use it? They will use it like this also. A power 4 minus B power 4. That can be written as a square minus b square. That would be a square plus b square, a square minus b square, because it also fulfills the category of difference of two squares. This is a square being squared. This is b square being squared. So that is a square plus b square, a square minus b square. Something like this. I could write it symbolically. Some other symbols can be used. S power 4 minus C power 4. Write it again. S square minus C square. So that is S square plus C square, S square minus C square. And I'll talk about this in the chapter of trigonometry of AS level maths. Got the idea? So that's how this factorization is used. Now, let's talk about simultaneous equations, something that we take for granted. When we talk about simultaneous equations, let's talk about simultaneous equations. Let's talk about coordinate geometry. Let's talk about sketching a line. Now we know that y is equals to mx plus c. If m is positive and m is negative, so now if m is positive, the line goes like this. If m is negative, the line goes like this. Okay. So now there are four possible graphs that I can make. So let me draw four grid over here. That is the first one. There is the second one. Then there is the third one. Then there is the fourth one. So now I have drawn four grids over here. And let me draw two more grids for something else. And over here, that's two more grids for something else. Now, if someone asks me to draw the line y is equals to 2x plus 3, and it's all about a sketch. If someone asks me to draw the line y is equals to 2x minus 1, if someone asks me draw the line y is equals to 3x plus 4, y minus 3x is equals to 0. And let me write y. This is positive, 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 positive. Y plus x is equals to 3. And y minus or plus 2x is equals to or equals to negative 1. Now, first of all, make sure that it's in the standard form y is equals to mx plus c. Y is equals to mx plus c, standard form. Y is equals to 2x minus 1, standard form. Y is equals to 3x plus 4, standard form. This becomes y is equals to 3x plus 0. Now it's in the standard form. Y plus x is equals to 3. Y is equals to minus x plus 3. Now it's in the standard form. Y is equals to negative 2x negative 1. Now it's in the standard form. So I hope just have a good look. It's all good, all clear. Standard form of equation of line. Now let me make a poll over here. Let me ask three things. How to plot this line? And the options are graph paper, and then some concept. So graph paper and table of values. So now just put a poll over here. Which one do you think is the right one? Go to your group. Graph paper and table of values and some concept. So let's see. Now someone is just asking how to join it. Okay. So now people are asking the foundation course. 3 people for graph paper and table of values, 9 people for some concept. And let me have a look. How many people are there in this thing? Okay, so let me just double check. Okay. Now, people, first of all, it's about a concept. That concept is right over here. If the graph has a positive slope, it's going to go up like this. It's like climbing up the ladder. If the graph has a negative slope, it's like climbing down the ladder. So positive slope. Which one has a positive slope? This one. And the y-intercept is also positive. So therefore, the graph goes like this. That's the y-intercept, which is positive, and the gradient is positive. Over here, y-intercept is negative. So therefore, this one goes like this. No one is going to measure with a protractor which angle is more steeper, which is less steeper, no one cares because it's a sketch. It has to be realistic. Positive slope, positive y-intercept. Positive slope, negative y-intercept. So this is negative y-intercept, which is -1. So this is -1. So this is positive slope, negative y-intercept. C is the y-intercept. I hope everyone knows this. Over here, positive slope, negative y-intercept. What about this? Positive slope, positive y-intercept. So positive slope, positive y-intercept. This thing is also there. This is positive slope, positive y-intercept. That is done. This one has a 0 y-intercept. So that means it will pass through the origin. So it will pass through the origin like this. This has a positive thing. So gradient is positive, C is 0. All good, all clear? Over here, negative slope, positive y-intercept. That's the negative slope. So let me choose the blue color line that goes like this. This is positive slope, which is 3, negative y-intercept. This is negative slope, negative y-intercept. Negative slope, negative y-intercept. So what I do is that, let me grab this thing and let me push it like this. Let me push it like this. And let me choose the blue line from here. And it's going to go like this. Something like this. Okay. And let me push this thing over here freehand like this. Okay. So now look over here. This is negative slope. Okay. And this is negative y-intercept. This is -1. And the slope is going down like this. So I hope this is all good, all clear. So first, acknowledge this is something very conceptual. Acknowledge if this is all good, all clear. The different sketches of straight line. Let me write it. Okay. Okay, all good, all clear. So these are different things that is used. Now, how can I use this for simultaneous equations? Let's say uh, y is equals to x plus y is equals to 10. And if I say solve simultaneously and show the result on a graph. So y is equals to x, that is a straight line. X plus y is equals to 10. That's another straight line, which I can write it as y is equals to minus x plus 10. So if I solve simultaneously, I can say y equals to x, y equals to negative x plus 10. So I can write x is equals to negative x plus 10. 2x is equals to 10. X comes out to be 5. Since y equals to x, therefore y also comes out to be 5. So if they ask for solution of simultaneous equation, then x is 5, y is 5. That is the answer. Now, if I do this thing, y is equals to x, y is equals to minus x plus 10, draw a sketch of each line and find the coordinates of point of intersection. So this is point of, let me write over here, intersection of both the lines. Now, Let me draw the grid. So over here, that is the grid. Let me draw the red line, y is equals to x. So that is a line going like this, because y is equals to x is basically y is equals to x plus 0. It has a positive slope. The coefficient of x is 1. The y-intercept is 0. The y-intercept is 0. Over here, the blue line, the slope is negative. Gradient is negative. And y-intercept is positive 10. This is positive. Okay. So now the blue line, let me draw the blue line that goes like this. It's not drawn to scale, just a rough diagram. The red one, this is y is equals to x. The blue one, that is x plus y, x plus y equals to 10, or y is equals to minus x plus 10. What is this? This is the coordinates of P, the point of intersection. So now your working is the same as before. And x is 5, y is 5. Therefore, the coordinates of P would be 5, 5, and this is obtained by simultaneous equations. So now let me pause for a few minutes. Let me share these images with you so that you can copy it, so that you are not lost. So let me just share the very, very important images so far. So let me pause the recording. So now, people, we are talking about a bit more sketch. So now let's talk about quadratics, something very important. Quadratics is the heart and soul of maths. So quadratic equations, there could be two types. Y is equals to x square and y is equals to negative x square. When we talk about y is equals to x square, so let me draw a grid first and another grid over here. Okay. So y is equals to x square. This thing, no, over here, I'm just looking for one thing, which is this thing. Okay. Draw the shape. The graph goes like this. That is how the graph looks like. Grab it and touch it over here. So now where it is. That's the graph of y is equals to x square. Similarly, if I want to draw the graph of negative x square, it's upside down. This you have studied in O-level maths. So now y is equals to x square, y is equals to minus x square. What makes the difference? The difference lies over here. If the coefficient of x square is positive, that's the shape of the graph like this. If the coefficient of x square is make sense? When x is positive, y is positive. Let me write over here. When x is positive, x square is positive, therefore y is positive. You can also draw a table. For right now, let me draw a table. You have x, you have y, negative 2, negative 1, 0, 1, and 2. And you are squaring them. So this is 4, 1, 0, 1, 4. Got the idea? Over here, this is x, this is y. There is a minus sign on the outside. Negative 2, negative 1, 0, 1, and 2. The same values will be there, 4, 1, 0, 1, 4. But because of the negative sign, negative 4, negative 1, 0 remains as it is. Negative 1, negative 4. Now, first have a good look at this. Are these two basic sketches? The basic sketch of quadratics, is this all good, all clear? Just acknowledge y is equals to x square, y is equals to negative x square. Now what I'll do is that I'll be using these sketches for simultaneous equations also. So if I use these sketches for simultaneous, how can I use it? Let me solve the equation y is equals to x and y is equals to x square. And I'll say this is y equals to x. This is y equals to x square. In other words, x equals to x square. Now there are two options. First option, divide by x. Second option, that is take common. So now over here, let me write this thing, which is the correct option. So this is options available over here. The first one, divide by x. The second option, take common. Now vote for this. Which is the correct one? The red option, the blue option. Divide by x, take common. Start. Yes, people. Divide by x. Good. Divide. Okay. Common, बेचारा एक, only one person, and that also person backtracked. क्या हो गया भाई? People, don't go with the majority. Take common. अच्छा. Others, कहाँ हैं आप लोग? Two people, 7-2, 7-3, 7-4, 8-4. जल्दी जल्दी. चले. Let me wait over here. The others, so many of them, are you people undecided? क्या कर रहे हैं भाई आप लोग? So now x is equals to x square. Let's see both of them. If I divide by x, x divided by x, that is x square divided by x over x is 1, x is equals to 1, that is the answer. If I take common, then x minus x square is equals to 0. You can take x common, x minus 1 equals to 0. Two brackets are multiplying to give you 0. That means either one of them is 0. So either x is 0 or x minus 1 equals to 0. Therefore, x is 1. Now, here is the verdict. The verdict is this is complete solution. The other one is incomplete solution. So this is incomplete solution. Now, the first thing that I'll write is this thing. Always take common. This is the first priority. Taking common is the first priority, no doubt about that. Now, why is this correct? We can show it graphically. So if I show it graphically, let me draw the graph of y is equals to x. That's over here. And let me draw the graph of y is equals to x square. So let me draw the graph of y is equals to x square. And that goes like this. So now let me just grab this thing and place at the right place. Now look at this whole graph from here, from this perspective. Now can you see it? This is the graph of y is equals to x. That is the straight line. So this is the graph y is equals to x. The blue one, that is the graph y is equals to x square. How many points of intersection do you see? This is one point. This is the other. This is the value x is equals to 0. This is the value x equals to 1. Got the idea? So we can see from the graph that there are two solutions of these two equations, two solution of this equation. Y is equals to x, y is equals to x squared. So this becomes x is equals to x squared. There are two solutions. Therefore, taking common is correct. this is incomplete solution. Is all good, all clear? So all good to go. So now just put a star over here and let me know if it's all good, all clear. This is the graph. This is the working, the algebra. And this is how it's evident from the graph. So always remember, in AS level maths, people ask this question. In AS level math, everything is linked. So if it's linked, then we have algebra, the calculation, we have graphs, sketches. So they both thing should tell the same truth. It's not possible that your answer from calculation should be different from this. The two answers should match, should be compatible. So now what have you learned? You have learned always take common whenever there is a possibility of taking common, because that is the first priority. Now, why don't you try out? Y is equals to 2x, y is equals to x square, and do the working by calculation, by graph. I want to see the solution. I'll show you the solution. You can just double check with mine. So take 5 minutes, find the answer for this. Let me pause the recording. So now people, let's look at the solution. The first thing that I'll be doing is algebra. So the first thing over here is solving using algebra, and now it would be very quick. Y equals to 2x, y equals to x square is equals to 2x, x square minus 2x equals to 0, x common x minus 2 equals to 0. Two things multiplying to give you 0, either one of them is 0, therefore x is 0, x minus 2 is 0, therefore x is 2. So there are two solutions of this equation. Got the idea? If you want the y value, y is equals to 2x. So therefore, when x is 0, y is 0. When x is 2, y is 4. If you want the coordinates, this is solution of simultaneous equations. If you want coordinates, the first coordinate is this thing, which is 0, 0. The other coordinate is 2, 4. Got the idea? And let me add a page over here. Let me also show it graphically. So if I want to show it graphically, so I have this thing. Let me push this thing in the middle. And we have y is equals to x square. So the blue color thing over here, that is over here. Let me draw it properly. Let me grab this thing. That is the graph of, hold for a second, that is the graph of y is equals to x square. And then the red line, that is the graph of y is equals to 2x, something like this. Okay, let me just push it, make it realistic. Now, something like this. Now look at the working. This is one answer. This is the other answer. That is how we get this thing. This is one point, which is 0, 0. This is the other point. It's not drawn to scale. This is 2. This is 4, 2, 4. The red line, y is equals to 2x. The blue curve, y is equals to x squared. So you have learned something new, which was not there in O-level maths. That is, you are solving one line, one curve. This line is a linear equation. This curve is a quadratic equation. So you have learned to solve simultaneous equations in which one equation is linear, the other equation is quadratic. And the lesson for today is always take common whenever there is a possibility of taking common. So let's stop over here. That is lecture number 3 and then lecture number 2. And inshallah, in the next class, we will start with lecture number 3. Take care, everyone.